This is section 9.4 of Honors Algebra 2, ellipses. Ellipses are the third of our four conic sections. So we've seen parabolas and circles already. Now we've got ellipses. An ellipse is essentially a circle, but elongated in one direction. An ellipse is the set of all points P in the plane such that the sum of the distances from P to two fixed points is a given constant. If you remember the circle, we had one fixed point, the center, and a fixed distance, the radius, and we took all the points that were that fixed distance away from the center. Now we've got two fixed points, which we will each call a focus, and we will take the sum of the distances from each of those points. We will add up those two distances, and we want that sum to be a constant. Each of those fixed points, again, we call a focus, so there are two foci of the ellipse. Foci is the plural of focus, so it's not focuses, foci. An ellipse has two foci. Here's an animation of how that works. You'll see the blue line is the distance from the left focus, and the red line is the distance from the right focus. You'll see the length of the blue line and the length of the red line changing as we go around the black curve, which is the ellipse. But you'll notice that the total length, the blue line plus the red line, is always the same. In this case, it's always 10. So this is an ellipse with a sum of focal radii, a fixed distance of 10. Every point on that black curve has a sum of 10 for its distances from the two foci. Okay, notice the foci are in the middle, and that they lie, in this case, on a horizontal line with each other. All right. Close that out. Okay, so how do we find the equation of an ellipse? Great question. Consider the ellipse with foci f1, which would be the point -4, 0, and f2, which would be the point 4, 0, and fixed distance, so the sum of focal radii, of 10. Okay? So let me quickly sketch what that looks like. We're at -4, 0, and 4, 0. Those are my foci. So those points are not on the ellipse, but they're points that are defining the ellipse, and a fixed distance of 10. Okay, let's apply the distance formula. If a point P is on the ellipse, so let's say that point is my P, x comma y, it's on the ellipse, only if the distance from P to F1, which is PF1, plus the distance from P to F2, which is PF2, is 10. Okay? So I can apply the distance formula for each of those two distances. The distance from P to F1 is x minus -4, which would be plus 4 squared, plus y minus 0 squared, so y squared. Then that will be plus PF2, so it's the square root of x minus +4 squared plus y minus 0 squared, so y squared again, which equals 10. So I've got those two distances. By using the distance formula, if I add them up, I need to equal 10. So I'm going to simplify this equation. I'm going to get rid of the square roots. Should I just square both sides the way they are? No, absolutely not. Remember from last semester, when we've got variables underneath the square roots, we want to isolate one of those radicals and then square both sides. So let's isolate the one on the left by moving the other one to the right-hand side. So x plus 4 quantity squared plus y squared equals 10 minus the square root of x minus 4 squared plus y squared. Now I can square both sides, which will eliminate the square root on the left side. And I'll go ahead and FOIL out x plus 4 quantity squared. That'll be x squared plus 8x plus 16, then plus a y squared. On the right-hand side, I'm going to FOIL that out. So I'll take 10 squared, that's 100, minus 2 times 10, which is 20, times the square root of x minus 4 quantity squared plus y squared, plus what I get when I take the square root of x minus 4 quantity squared plus y squared and square it. Well, that's just x minus 4 squared plus y squared. Okay? Now, I've got a y squared on both sides. I can cancel those. And if I take this x minus 4 quantity squared and I FOIL that out, that gives me x squared minus 8x plus 16. Now I've got an x squared on both sides. I can cancel those. I've got a 16 on both sides. I can cancel those. And I've got an 8x on the left side, but a negative 8x on the right side. Can I cancel those? No, because they're opposite signs. So instead I'm going to bring them both to the same side. And I'm going to take this negative 20 square root of x minus 4 quantity squared plus y squared and move it to the left side. So let's do that real quick. I'll have a 100 minus a 16x on the right-hand side. That's a negative 8x that was already over there, minus the 8x that I moved over from the left-hand side. Now, to save time in this video, I'm going to jump ahead, and magically, pop! I end up with this, 9x squared plus 25y squared equals 225. Okay. What we're going to do with that is divide everything by 225. So the 9x squared I'll divide by 225, the 25y squared I'll divide by 225, and the 225 on the right hand side I will divide by 225. Okay? 9 goes into 225 25 times. So this is x squared over 25 plus y squared over 9 equals 1. And that is the equation of my ellipse. An equation of an ellipse will always be equal to 1. So if I have another number on the right-hand side, I will divide everything by that number so that I am equal to 1. That's the equation of my ellipse. Now how do I graph this ellipse? X squared over 25 plus y squared over 9 equals 1. How do I graph that? Well, easy points to graph are the intercepts. So what are the intercepts? If x is 0, what is y? Well, if x is 0, I've got 0 squared over 25, which is 0, and all I have is y squared over 9 equals 1, or y squared equals 9, which means y equals plus or minus 3. So I've got two y-intercepts. One at positive 3, 0, 3, and one at negative 3, so 0, negative 3. What happens when y is 0? Well, that will just leave me with x squared over 25 equals 1, or x squared equals 25. So x equals plus or minus 5. There are two x-intercepts. One at positive 5, 5 comma 0, and one at negative 5, negative 5 comma 0. This has four intercepts, two x-intercepts, two y-intercepts. Well, how is the graph limited? What do I mean by that? Well, the graph is not going to go on forever. It's like a circle. It's a limited curve. So if I were to take my equation and solve it for y, and you could do this and verify that I'm correct, you'll get y equals plus or minus 3/5 times the square root of 25 minus x squared. So that means y is limited by what x is allowed to be, because x can't be anything. I can't have a negative number underneath that square root, so x can only be between negative 5 and 5. If x is beyond negative 5, so further negative than negative 5, or beyond positive 5, then I'll end up with a negative number underneath that square root, and I can't do that. So x is between negative 5 and 5. That means y is limited by x being between negative 5 and 5. Similarly, if I were to solve that equation for x, my original equation, I'll end up with x equals plus or minus 5/3 times the square root of 9 minus y squared. And similarly, y has to be between negative 3 and 3 in order to end up with a non-negative number underneath that square root. Okay, so x can't go past 5 or past negative 5. Y can't go higher than 3 or lower than negative 3. So it turns out that I'm bounded between the sides of this rectangle. If x can't go beyond negative 5, and y can't go lower than negative 3, then I have to be there. If y can't go higher than 3, or x can't go beyond 5, then I'm stuck in this rectangle. That just visually gives me a sense of how I need to draw my graph. So, from there, the ellipse will look something like this. And we could plot more points if we wanted to, but they're not going to be exact numbers. That all would be decimals, decimal approximations. but my ellipse looks something like that. So it's completely rounded, it's curved, it's not a football shape, but it's an oval like that. Is the graph symmetric? Yes, it is. It is symmetric about the y-axis and about the x-axis. Awesome. Notice that if we call 0, 0 the center of the ellipse, then the distance to the focus is 4. Remember, we had our foci all the way at the beginning of the video being at -4, 0, and 4, 0. So if our center is at 0, 0, the distance to the focus is 4. The distance from the center to the end of the ellipse along the x-axis is 5. And the distance from the center to the end of the ellipse, the top of the ellipse, along the y-axis is 3. So, if we call 0, 0 the center of the ellipse, the distance to the focus is what we'll call C, which is 4. The distance to the furthest points on the x-axis is what we'll call A, which is 5. And the distance to the furthest points on the y-axis is what we'll call B, which is 3. Thus, our equation that we had, x squared over 25 plus y squared over 9 equals 1, is actually of the form x squared over a squared plus y squared over b squared equals 1. Where a is 5, so 5 squared is the 25 that we had, and b is 3, so 3 squared is the 9 that we had. Is there a significance to these numbers a, b, and c? Where a is 5, b is 3, and c is 4. Yes, there is. If you think of geometry, these numbers form a Pythagorean triple, 3, 4, and 5. So it would be the case that b squared plus c squared equals a squared. 9 plus 16 equals 25. Or, as we'll write it, c squared equals a squared minus b squared. And that will always be the case for an ellipse. Why? Great question. A question you should be asking, and a question you should ask me in class tomorrow when I'll show it to you. So this is all fine and dandy if the ellipse happens to be centered at 0, 0. In that case, the x-axis is the major axis. It's the chord containing the center and the foci. So it's the longer axis. It's the major one. The y-axis is the minor axis, the chord containing the center that's perpendicular to the major axis. That should say major. So it's the shorter one. The minor one is the shorter one. So what if it's not centered at 0, 0? It certainly doesn't have to be. It could be anywhere in the coordinate plane. That brings us to these formulas. If our ellipse has a center of h, k, same letters we use for the center of a circle and for the vertex of a parabola, then there's two options. Either its major axis is horizontal, so it's elongated like this, or its major axis is vertical, so it's elongated like this. If its major axis is horizontal, then the a squared is underneath the x term, and the b squared is underneath the y term. In that case, the foci are a distance of c away from h, so that it's horizontal. If it's a vertical major axis, then the b squared is underneath the x, and the a squared is underneath the y term. And in that case, the foci are a distance away from k, so that it's vertical. Then you're adding and subtracting c to the y coordinate of the center, where c squared is always a squared minus b squared. And a useful fact is the sum of focal radii, that fixed sum of distances, is always 2a. Why? Great question. The question you should ask me in class tomorrow and I'll explain it to you. So, a few examples. Graph 4x squared plus y squared equals 64 and find its foci. Well, is that an ellipse? Yes, it is. But remember, we want it equal to 1, so let's make it equal to 1. We'll take it and we'll divide everything by 64 so that we have a 1 on the right-hand side. Okay? Well, what's 4x squared divided by 64? Well, 4 goes into 64 16 times. So this is really x squared over 16. Plus y squared over 64 equals 1. Okay. Now, that's in the form that we wanted, where a, which is always the bigger one because a is the distance along the major axis, A, or A squared, is 64, so in this case A is 8. B is the smaller of the two numbers. B squared is the smaller of these two numbers, so that's 16, and B is 4. So A is the distance along the major axis, so it's the longer one. B is the distance along the minor axis, so it's the shorter one. But A, in our equation, A squared was underneath the Y squared term. That means that this ellipse is elongated vertically. It's a vertical ellipse. So I'm going to go from my center, which must be 0, 0 here because I'm not subtracting or anything onto x or y before I'm squaring them. My center must be at 0, 0. And if I go up 8 and down 8 from that, I will have the furthest points along the major axis. So that will be at 0, 8 and 0, negative 8. If I go to the left and the right by 4, which is B, I'll have the furthest points along the minor axis, 4, 0 and negative 4, 0. And now I've got enough to draw the ellipse. Something like that. Okay? I also need to find its foci. I find the foci using this relationship that c squared equals a squared minus b squared. So c squared is going to be 64 minus 16. Well, what's 64 minus 16? 48. So c squared equals 48. So c is, in this case, the positive square root of 48. Well, 48 divided by 16 is 3. So this is really 4 square root of 3. So what are my foci? My foci are going to be a distance of 4 radical 3 away from the center, but away in the y direction. So I'm going to add and subtract 4 radical 3 from the y coordinate of the center, which is 0 here. So my foci are at 0, comma 4 radical 3 and 0, comma negative 4 radical 3. Example number 2. Find an equation of ellipse having foci at negative 3, 0 and positive 3, 0 and a sum of focal radii equal to 12. Okay? So sketching what I know, there is a focus at negative 3, 0 and there's a focus at positive 3, 0. So that means my ellipse must be positioned horizontally. And the sum of focal radii is equal to 12. Well, I told you the sum of focal radii is always 2a. So 2a must be 12. That means a equals 6. Okay? The center is halfway between the two foci. So the center here must be at 0, 0. So I've got a center at 0, 0. That means h is 0, k is 0. A is 6. C is 3. C is the distance from the focus to the center. So I'm going to use those to find B, knowing that c squared is a squared minus b squared. So 9 equals 36 minus b squared. Okay? So that means b squared must be 27. So what is b? B is square root of 27, which is 3 radical 3. Okay? So now I have enough to form my equation. Center's at 0, 0, so I've got x minus 0 squared, so x squared, over, since this is positioned horizontally, the bigger number, which is always a, needs to be underneath x. So this is a squared, which is 36, plus y minus 0 squared over b squared. Well, what's b squared? That was 27. So I don't really need the 3 radical 3. I just need b squared. And this always equals 1. Notice the c does not end up in my equation, but I use it to find the b. Example number 3. Find an equation of the ellipse having foci at negative 3, 4 and 9, 4 and a sum of focal radii of 14. So this time, this is not centered at 0, 0, because I've got a focus at negative 3, 4 and 9, 4. So the center is going to be halfway between those. It's going to be the midpoint of the line segment that contains those. So let's apply the midpoint formula. The center is going to be at, well, 9 plus negative 3 over 2, comma, 4 plus 4 over 2. Notice the y-coordinate is just going to be the same as the y-coordinate of the two foci I've already got, or the y-coordinate of the two foci. So that's 4. 4 plus 4 over 2 is 8 over 2. 9 minus 3 over 2 is 6 over 2, which is 3. So my center is going to be at 3, comma 4. Good. The sum of focal radii is 14. That means 2a is 14. So a equals 7. Okay, what is c? Well, c is the distance from the center to the focus. What's the distance from 3, 4 to 9, 4? That's 6. Okay, so c squared equals a squared minus b squared. That means 36 equals 49 minus b squared. So b squared must be 13. So my equation will be x minus 3 quantity squared over, since this is positioned horizontally, the foci are on the same horizontal line as the center, then the a squared is going to go underneath the x squared. So this is over 7 squared, which is 49, plus y minus 4 quantity squared, since my center was at 3, comma 4, over b squared, which is 13, and that equals 1. There's my equation. And here are your immediate practice problems. Number 1, graph 16x squared plus 25y squared equals 400 and find its foci. So of course the first thing you're going to do is divide everything by 400 so that it's in the form of the equation of an ellipse. Number 2, and that will, number 1 will be just like example number 1. Number 2, find an equation of the ellipse having foci at 2, 1 and 2, negative 3 and a sum of focal radii of 6. This will be just like example number 3, however, it will be a vertical ellipse. And that is the end of section 9.4.